The green fields of wheat and swinging earheads are the basis of national food security. The golden grains are the source of extreme happiness to the farmers. Behind this prosperity and satisfaction lies the hard work of the farmers. The hard-working farmers fulfill the requirement of every citizen by producing over 70 million tons of wheat from an area of approximately 25 million hectares. As a result, the country has presently sufficient wheat in its godowns to meet any emergency. Although the situation is satisfactory, it's not sufficient to meet the future requirements. Therefore, it would be necessary to increase wheat production at the minimum production cost, maintaining improved quality in the context of World Trade Organization's regulation. The current production needs to be increased by 35 million tons by 2020 through increased productivity, because there is not much scope of increasing the area under wheat cultivation. To achieve this production target, it would be necessary to integrate high-yielding varieties and better production technologies. Known as the resource conservation technologies, awareness about these technologies is fast spreading amongst the farmers. By adopting these technologies, the cost of production can be reduced, leading to increased income to the farmers. Soil conditions improve, leading to sustained level of production. By adopting these technologies, the Indian wheat is becoming more competitive in the global market. Established by the Indian Council of Agricultural Research, the Directorate of Wheat Research at Karnal, since its inception, has been involved in developing such resource conservation technologies and popularizing them among the farmers. For cultivating wheat, a multi-purpose and useful technology is zero tillage. It has proved its utility in the rice-wheat cropping system. After becoming popular in Haryana, its popularity is now spreading to Punjab and northeast India. Conventionally, in the rice-wheat cropping system, after harvesting paddy, the field is prepared by undertaking 6 to 12 tractor operations with various implements depending on the soil conditions. Apart from consuming more time and labor, it involved heavy expense on tractor fuel. Zero tillage helps cultivation with a specially designed seed-cum-fertilizer drill machine, that is, zero till drill machine. In this machine, the shape of the tines are like a knife, which make a narrow slit into the soil to place the seed and fertilizer at an appropriate depth. To increase or decrease the depth of sowing, the machine has been provided with balancing wheels on two sides, which, with the help of screw bolts, can be raised or lowered. A driving wheel is provided in the front, which can be adjusted through a groove. There are two boxes in the back of the machine, one for seed and the other for fertilizer. Each box is fitted with a lever and scale to adjust the quantity of seed and fertilizer application in the field. At the back of the machine, there is a provision of a wooden platform enabling a person to sit and keep a watch on seed and fertilizer tubes. With this machine, about 2-acre area can be sown in an hour. Due to time saved in field preparation with zero tillage, wheat sowing can be advanced by 5 to 10 days. Fear of late sowing is avoided with this technology. This technique enables sowing of wheat in normal as well as in late sowing conditions. It saves about Rs 2 to 2,500 per hectare in overall field preparation cost. Single tractor operation saves up to 92% diesel usage. Because of lower diesel consumption and not burning of paddy residue, the pollution is also controlled. Thus, Being environment friendly, it gives an additional benefit. For better production through zero tillage, seed and fertilizers are applied at par with the recommended doses of the conventional method. Water requirement is slightly lower as compared to conventional tillage. Sowing of wheat through zero tillage reduces infestation of Phalaris minor known as Mandusi, Kanki or Gulli Danda, since the seeds of weeds remain buried deep in the soil and get no chance to germinate. Another resource conservation technology developed for wheat cultivation is popularly known as bed planting or FERB system. In this system, field is prepared according to conventional method and thereafter raised beds are made on which wheat is sown. The furrows prepared between the raised beds are used for irrigating the crop. The same furrows are also used for draining out the extra water during rains. The beds and furrows are prepared with the help of a machine known as bed planter, which also applies fertilizer along with sowing of seed. Generally, the width of each raised bed is kept 65 to 75 centimeters on which seed is sown in 2 to 3 rows. In bed planting machine, there is an arrangement to adjust width and height of beds. For this, there are holes on the frame at a distance of 1 inch and tines are adjusted inside or outside. The height of beds can be adjusted with the help of rollers fitted on the rear of the machine. As in zero tillage machine, the tines fitted in this machine are also like a knife. With the help of bed planter, after cultivating wheat, other crops can also be grown on the same beds in a single operation without any field preparation and vice versa. During Kharif, the crops like maize, soybean, pigeon pea and cotton can be grown on the beds, whereas wheat, mustard, potato, peas and other vegetables can be grown during Rabi season. Efforts are also on to explore the possibility of growing paddy on the same beds after the harvest of wheat. Thus, there is a saving in time, labor and diesel required for field preparation. These benefits are in addition to other normal benefits of bed planting technology. In bed planting, there is a saving of 25% in seed and fertilizer as compared to the usage in conventional technology. In addition, depending upon soil and climatic conditions, there is a saving of 25 to 40% of irrigation water and production is also good. On an average, 1 to 1.25 acres per hour can be sown with the help of a bed planter. In bed planting system, infestation of Mandusi is less because the upper surface of the beds dries out faster and the seeds of the weed lying in dry zone fail to germinate. Even if on the bed surface or in furrows some weeds germinate, it is easier to remove them manually. The farmers can do it easily by moving in the furrows. Thus, the bed planting technology is also environment friendly. For better production in bed planting system as compared to conventional system, 1 to 2 additional irrigations are given. But since per irrigation almost half of the water is used, there is substantial saving of water. In northwestern India, generally the farmers do not apply last irrigation due to the fear of lodging of wheat crop. However, in the bed planting system, since the plants do not come in direct contact of water, therefore advantages of last irrigation can be derived. Bed planting system is also ideal for seed production of wheat. With the advantage of removing unwanted plants in this technique, it is easy to maintain the purity of seed. Each plant gets ample light that helps in realizing better production. After becoming popular amongst farmers of northern Rajasthan, bed planting system is also attracting farmers of Punjab and Haryana. Rotary tillage technology is another important achievement in the area of resource conservation technologies. Known as rotary till drill machine, it performs 4 operations in one go. It pulverizes the soil and simultaneously places required quantity of seed and fertilizer at appropriate depth and planks the field. Therefore, the tractor is driven only once, whereas in conventional method, 6 to 12 tractor operations are required. Thus, it saves diesel, labor and time to the tune of 70 to 90%. In other words, the total cost involved in field preparation is reduced by about Rs 2,000 per hectare. Owing to saving in time, wheat can be planted under both normal and late sown conditions immediately after paddy harvest. In addition, it enables 7 to 10% higher yield as compared to other technologies. In rotary tillage machine, rotary tiller does the main function on which there are 7 gangs of blades. On each gang, 6 L-shaped blades are fitted which rotate at a speed of 300 rpm. It prepares 180 centimeter wide strip for sowing. Rotary tiller machine pulverizes the soil up to a depth of 7 to 10 centimeters. 9 to 11 rows for placing of seed and fertilizer together can be possible with a drill fitted on the rotary unit. Raising or lowering the tines can adjust the depth of seed and fertilizer. Also fitted on the rear is the planking attachment. Scientists have developed another beneficial resource conservation technology known as surface seeding. No machine or tillage is required in this system. In view of excess moisture condition in paddy field a few days before or immediately after paddy harvesting, dry or water immersed wheat seeds are sown. For protecting wheat seeds from birds, the seeds are coated with cow dung and then broadcasted in the field. This technology is beneficial in those areas where wet conditions prevail for a longer time after paddy harvest and the fields cannot be prepared for wheat sowing. As a result, the farmers are forced to remain contented by growing only one crop in a year. Due to such conditions, growing of wheat after paddy is not prevalent mainly in low-lying areas of East Uttar Pradesh, Bihar and West Bengal. However, surface seeding provides an opportunity to grow wheat after paddy. Cost of production is also reduced due to saving in field preparation cost. Surface seeding technology provides an opportunity to increase income of resource-poor, small and marginal farmers. Recently, another effective technology has been developed which gives exceptionally good results. For perfect leveling of the field, laser land leveler machine has been developed. Tractor-driven and laser-operated, this machine makes the field even just like a tabletop. Using the laser rays and hydraulic system, it automatically adjusts the scraping blades fitted behind the tractor. In this process, The soil is scraped from higher places and filled in depressions to make the land completely leveled. Laser land leveler has 4 parts called laser transmitter, laser receiver, control box and hydraulic unit. The laser transmitter emits rays which helps in identifying higher and lower areas. The laser receiver is attached to blades and sends the signals to the control box. After analyzing laser signals, the control box prepares necessary conditions for the blades to operate. Lastly, the hydraulic unit raises and lowers down the blade. It has been observed that 20 to 25% of irrigation water is wasted if the fields are not properly leveled. At the same time, crop production is adversely affected in undulated fields due to accumulation of water in lower parts and dry condition at some other place. By adopting laser land leveling technology in crop production, the irrigation water is efficiently used. It also helps increase in the crop yield by 10 to 15%. The improved resource conservation tillage technologies developed by the agriculture scientists have paved the way for the farmers to save money, labor, fuel and time. Promising sustainable production and being environment friendly, the resource conservation technologies are being widely adopted by the farmers. These technologies have provided opportunities to increase wheat production and productivity in the country. The synergy between farmers and scientists is spreading its magic in the fields. The target of 109 million tons of wheat production by year 2020 is now looking easier. Let us adopt these technologies for providing a solid platform to the food security of the nation.